on so for this we're going to rely on information that we used in the last lesson, that we learned in the last lesson. Okay, so we're gonna solve rational equations today, right? Basically, this is an equation that has variables in the denominator. Okay, now here are some steps to how you solve rational equations. First, factor any terms that are factorable, okay, numerator, denominator, whatever. Then determine the LCD, just like we did before. So you go through all of the fractions and you have to determine the LCD. You have to multiply each term with the LCD. This is important, every single term. Eliminate common factors and then solve. Okay, so let's do one. The first one here, is there anything that needs to be factored? No. So I'm done with number one. Number two, determine the LCD. What's the LCD for this one? 24 times 3 minus x. So what I want to do now, these steps are wrong. Okay, the next step, multiply each term with the LCD. So I multiply each term by 24, 3 minus x, 24, 3 minus x, 24, 3 minus x. This is like equal opportunity multiplying. You cannot multiply one term and forget about the other one. Not cool, not fair. They just throw a fit, okay? Now, you have to go to each individual term and simplify or cancel out whatever can be canceled out. All right, the first one here, you've got the red times 5 over 24. You see how I can cancel out the 24 with the 24, right? So what do I have left? 5 times 3 minus x. Right, we'll do that in the next step. Plus, what can I factor out here? What can I cancel out here? 3 minus x, 3 minus x. And I'm left with 2 times 24. Equals, what can I factor out there? What can I cancel out there? 24 and 4 giving me a 6. And I have 6 times 3 minus x. Okay, let's just pause for a minute and look at what we've done. What have we eliminated by doing this? All of the denominators, right? All of the denominators. If after you do this, you still have some denominators left over, go back, you did something wrong, okay? Now, it's just a simple old algebraic equation, which we've been solving ever since we were little. So, distribute plus 48 equal to 18 minus 6x, right? Here I have negative 5x plus 48 plus 15. What do we have there? 63 is equal to 18 minus 6x. Now, I'm going to add 6x to both sides. So I get x plus 63 is equal to 18. I'm going to subtract 63. So how much is that? How much? Negative 40. Is it 41? Yeah. No. 45. Okay, so 63 minus 10 is 53, minus 8 is negative 45. So there you have it. Now, one thing I neglected to do, before you even start, it said here to state the restrictions, and I was like, I had missed solving these equations so much that I just wanted to jump into it, and I'm sorry I forgot to do that first. State the restrictions. If you go back to your original equation, remember what restrictions are? These are the values that make any of the denominators 0. What restrictions are there here? X cannot equal 3. That's the restriction. So now you look at your answer. Did I get 3? I did not get 3, so I'm good to go. Yay. Okay? All right, here. What is the restriction for this next one? None. None.
You didn't write restriction.
I mean, I'll ask you. I mean, it depends, right? Let's take a case by case. Like if you have a space for it. Okay, so LCD is what for this one? 18. It's the number, it's the smallest number that both can be divided by. So I'm going to multiply everything by 18. Yeah, the x and the 3 don't have denominators. It's okay. Don't hurt their feelings. Give them an 18. Okay? Now, what have I got left? Here, 18 times x plus 18 times 3 plus, what happens here? The 6 and the 18 gives me a 3. 15 equals 23. Okay? So here, I have 18x plus... Oh, yeah, but what happened with the 18s? They canceled. Beautiful thing there. So here I have 18 times 3 plus 15, which is 69, equals 23. Subtract, subtract. So I get 18x is equal to negative 46. Divide by 18, divide by 18. X equals negative 46 over 18. On the test, that would give you a -1 because what else do I have to do now? Simplify to what? Negative 23 over 9. Thank you. Okay? Waiting. Okay. Okay. So an extraneous solution, we've come across this in logarithms, right? This is a solution that does not make the equation true, or basically it's an equation that, you know, makes it's a solution that is artificially introduced to a problem, okay, which otherwise may not have been there. Okay, so they need to be eliminated, right? So basically, if there is an answer that doesn't work in the equation, that's an extraneous solution. Okay, let's take a look at this one. Let's write some restrictions here. What is the restriction for this one? X can't be -5. Okay, you know what? Before we do the restriction, why don't we factor first? Can I factor this one? That gives me x plus 3, x plus 5. And then what about this one? That can't be factored, so we just leave it that way. Huh? No, we can leave it like that. So the restrictions are x can't be -5 and x can't be -3. Okay, now what's the LCD? X plus 3, x plus 5. Whose is the other one? Oh, okay, cool. It's okay, we got x plus 3, x plus 5. Okay, let's multiply everybody with that. I love this stuff, guys. I miss them. Oops, I switched the order here. I wrote x plus 5, x plus 3. Does that matter? No. Not at all. Good. So, what cancels in the first one? X plus 5. What about the second one? Both of them. And what about the third one? X plus 3. So, let's clean house here. See what we've got left. 2x, x minus 3. Oops, plus 3. Minus x squared minus x minus 10 equals 3 times x plus 5. I intentionally left a mistake in there. Where's my mistake? What about it? You need parentheses around that one, okay? I'm envisioning what I see when I'm grading the chapter 8 tests year after year after year after year after year. And that's one thing I always see. So now let's distribute these guys. And I get 2x squared plus 6x minus x squared plus x plus 10 equals 3x plus 15. I love quadratic equations. Okay. 2x squared and x squared gives me a negative x squared is just x squared plus 7x plus 10 is 3x plus 15. Can I subtract a 3x here? Why not? Can I subtract the 15? Why not? So now I have x squared plus 4x minus 5 equal to 0. Look at that, guys. There is an end in sight. Beautiful. Thank you. So x plus 5, x minus 4 equal to 0. Thank you. X equals, that was not an intentional mistake. X equals negative 5 and x equals positive 1. But, what? That's a restriction. So you throw it away. That's an extraneous solution. And I'm left with x equals 1. Okay, like there has got to be something like gratifying about solving this stuff, right? I mean, it's amazing. Yep. I feel a Friday afternoon Shabbaton session coming up here. Just some rational equations. Huh? Right? I would rather do this all day than, I don't know what, like hang out on Terry Field? Psst, give me a break. Okay, that we can't do. Okay. Okay. So, what's going to happen here? What are we going to do here? Before that, can we factor 3n plus 1, 4n minus 1, 2n plus 1. Loving this problem already. What are my restrictions? N can't be positive 1 and n can't be negative 1. So I can also write n can't be plus or minus 1. Okay? Yeah.
Will they come out this neatly?
Hopefully.
Okay.
Okay. You're not able to eliminate? No, you will. Anytime you're solving rational equations, if you can't get rid of the fractions, if you can't get rid of the denominators, you're doing something wrong. Okay? All right. So, what's LCD here? I mean, yeah, that's what I'm saying. If you are doing it wrong. LCD? Okay, hang on. I'll get to that. There is an n plus 1. There is an n minus 1. And what about the coefficients? Not a 4, a 12. Good. So I start with the larger number, which is 4. And I say, okay, does 4 divide equally among the others? No. How about 8? No. How about 12? Yes. Okay, so let's multiply everything by that. 12, n plus 1, n minus 1. Okay. Here, okay, We got to be careful here. N plus 1s cancel, and what about the 3 and the 12? I get a 4. So you know what? Now that I can see it, I'm just going to write that part down. So I have 4, n minus 1, 7n. Minus, what cancels here? N minus 1, n minus 1, and the 4 and the 5 become, the 4 and the 12 become a 3. So I have 5 times 3, n plus 1. Because the 5 was already there, and then the 4 and the 12 made it a 3. Okay, then n plus 1 and n plus 1 will go away, and I will have 3n times 6 n minus 1. Okay, what's going to happen with this black here? It's 4 times 7n, 28n times this, right? So it's 28n squared minus 28n. Yeah, I'm just multiplying everything together. Should we, you know what, okay. So then, minus 15n minus 15. Am I skipping too many steps? Equals, this is 18n, 18n squared minus 18n. Okay, let's see what we've got. On the left side, 28n squared minus, how much is that? 28 plus 10, that's 38, plus 5, negative 43n minus 15 equals 18n squared minus 18n. Let's subtract 18n squared, and let's add 18n. Yay! So 10n squared minus how many? 25n minus 15 equal to 0. Okay, what can I factor out of this? A 5. So I get 2n squared minus 5n minus 3. Okay, so let's factor this. Let's do the shortcut. I can do it now because I factored out a 3. So the 5 stays. Now I have n minus 6, n plus 1. Putting the 2 back. 5, n minus 3, 2n plus 1. No, you just simplify it. Now, what is n equal to? 3 and negative 1/2. Okay, any of these restrictions? No. The restriction was just plus or minus 1. So this works and this works. So notice, right, when I factored out the 5 here, that's just a coefficient. It has nothing to do with my solution. It just like hangs out there, okay? I could have divided it out, but I didn't. Okay, next one. Ooh, I love these. Okay, we're going to factor z minus 1, z plus 1. And you know what? I'm going to like cross my z's here because of the 2's. Okay. What are my restrictions? Right. Okay, now, what's the LCD? Right, z plus 1, z minus 1. Okay. We're going to get rid of a z plus 1 and a z minus 1 and everything here. Don't get too carried away, like canceling things out and like get left with nothing, okay? So 2z minus 1 minus 1 z plus 1 equals just 2. Yeah? It's negative. That's what I said. 2z minus 2 minus z minus 1 equals negative 2. 2z and negative z is 1z minus 3 equals negative 2. So how much is z? 1. But z can't be 1. So what's up with that? No solution. Right. So we got z equals 1, but it can equal 1, and we don't have any other choice. So it's no solution.
Oh, so that's
Yep. Okay. Weighted averages. Who doesn't like a little, you know, mixture and percentage and blah, blah, blah. Okay. So Jimmy adds 65% fruit juice. Huh? No, this is not. Okay, thank you. So Jimmy adds a 65% fruit juice solution to 15 milliliters of a drink that is 10% fruit juice. How much of the 65% solution must be added to create a fruit punch that is 35% fruit juice? Oh my. Okay. So he's got some juice. He's got 15 milliliters of juice. Okay? Of a drink. And it's 10% fruit juice. Okay? Here, let's make it a little bit more. It's 10% fruit juice and 90% water, right? So somebody put in like a little bit of fruit concentrate and then a lot of water. Now, he's going to add to this a 65% fruit juice solution. He found another solution that has more fruit juice, so it's like nice and sweet. But this one tastes bland, like water, because it's all water, 10% juice. So he's like, you know what? I don't want this one to go to waste. I'm just going to add some of my good solution to this and dilute, and make this stronger a little bit. But if he's adding from one that's 65% to one that's 10%, right? He's going to come up with a concentration that's somewhere in the middle, right? So if the red one is like super sweet and this one tastes yucky, nasty like water, when he mixes them, the mixture is going to be somewhere in between. So how much should he add to get 35% fruit juice? That's like his preferred percentage of fruit juice, okay? So how much does he have to add in there? All right, so let's first talk about amount of juice, right? In the amount of juice, so how much original does he have? Like in his original, how much actual juice is there? 10% of what? Right, it's 10% fruit juice. It's Okay, so there is 15 milliliters, but only 10% of it is juice. So like only this much of it is juice, right? So 0.1 of the 15 is juice. Okay? He's gonna add, okay, and in the original, how much total solution does he have? 15. 15 milliliters, right? Just 15. Now, in the one that he's adding, right? In the one that he's adding, how much of it is juice? 0.65. So 0.65 of the amount that he's adding. How much we're adding, we don't know, right? Is juice. So how much solution is he adding? X amount. Okay, so let's review that a little bit. Let's go like bottom up. In the original, he's got 15 milliliters total solution, drink. Of that, 10% is actual juice. Now, he's adding in X milliliters more. Of that, 65% is actual juice. So, what is the new solution? The new solution, it's going to be 0.1 times 15 plus 0.65x. That's the amount of juice. And then 15 plus x, that's how many milliliters total he's going to get. Now, he wants this to equal 35% fruit juice. So the amount of juice over the total solution is going to be 35%. So 35 over 100, right? Or 0.35, it's up to you, right? We can do 0.35. Is going to be 0.1 times 15 plus 0.65x over 15 plus x. So how much actual juice over the total amount of how much drink there is? Okay? And now we're going to solve this just like before. So what's the LCD here? 15 plus 6. So we're going to multiply. This will cancel. So here I get 0.35 times 15. How much is that? How much? 5.25 plus 0.35x is equal to 1.5 plus 6.5x. Okay, let's subtract 0.35 this time. I'm sorry, 0.65x. Like from here to here? I'm just multiplying. Like from here to here, Andrew? So, sorry. Okay, so this was supposed to be 0.65x. So let's subtract 0.35x. So I get 5.25 is equal to 1.5 plus how much? 0.30x. Okay. Huh? Yeah. Okay, so then subtracting 1.5, 3.75 is equal to 0.30x. Divide by 0.30. And I get 12.5. Okay, so what have I solved for? I've solved for how much of this should I be adding, right? How much total should I be adding? So I need to add 12.5 milliliters. Okay? Huh? No, it's just 12.5 because it's asking how much must be added. So how much do I need to pour in from the red one in order to make the whole thing 35%? So total, my total in my container, I'm gonna have 15 plus 12.5, 27.5. This is just how much I'm pouring in. Okay? All right. So this homework is due tomorrow, plus you've got the practice quiz, which I will give you right now. And you notice it's just 16 to 22 all plus 35.